3I/ATLAS will not destroy Mars, but here's the shocking truth. It could rewrite what we know about the origins of comets and even other solar systems. While many people imagine devastation, scientists are calling this comet interstellar gold, an icy messenger flying past Mars at a safe 18.5 million miles. From that distance, Mars Reconnaissance Orbiter and Mars Express are busy pointing their spectrometers, hoping to catch chemical fingerprints locked inside since the birth of another star. The danger isn't Mars being wiped out, it's us missing this chance to study an alien traveler. But before we dive in, please hit subscribe and like the video. Your support means the world to us. It helps us grow the community and bring you even more exciting space discovery videos. Thanks a lot, and now let's dive in. Imagine hearing the words, "A comet is passing near Mars." Your first thought might be danger. It sounds like the beginning of a headline warning that future astronauts, colonies, or even robotic missions could be wiped out in a blink. The way it's framed makes it easy to imagine a fiery collision, and that's why this story spreads so quickly. The reality is very different, but the language of passing near is enough to trigger deep concern in anyone who isn't used to astronomical distances. That's the problem. Space doesn't measure closeness the same way we do here on Earth. Something that sounds close in space is usually unimaginably far by human standards. The closest approach of 3I/ATLAS to Mars is about 18.5 million miles. On first hearing that number, it doesn't mean much to most people, but think of it this way. The distance from Earth to the Moon is just under 240,000 miles. This comet will be nearly 80 times farther from Mars than the Moon is from Earth. If the Moon seems out of reach to us, now stretch that mental image into deep space almost 80-fold. That scale alone should drain away the fear of impact. Scientists also know more than just the numbers on a chart. The path of 3I/ATLAS is what's called a hyperbolic trajectory. That means it isn't circling the Sun like normal comets we hear about. Instead, it is flying on an open-ended route, far too fast and with too much momentum to ever become trapped in orbit. It comes in, sweeps by, and then continues outward, back into interstellar space. Because of this velocity, gravity from Mars or even the Sun itself cannot redirect it into a crash course. The mathematics are unambiguous here. The possibility of a collision with Mars simply doesn't exist. This isn't just an assumption. As soon as observatories collected tracking data on its position and speed, astrophysicists ran orbital models on supercomputers. These models use the laws of gravity and mathematics that have successfully predicted planetary positions for centuries. Right away, the outputs showed that while it would pass in the general neighborhood of Mars, the two bodies were never going to cross paths. It was destined to pass by undisturbed, a visitor just passing through before vanishing again into the void. Once you know this, the fear fades. But that does not mean the comet loses importance. In fact, what makes 3I/ATLAS special has nothing to do with danger. This object is not just any comet. It represents only the third time astronomers have ever identified something wandering into our solar system from another star system altogether. That rarity is almost as staggering as its distance from Mars. Just think. Beyond all the panic headlines and the imagined crashes lies a remarkable truth. This is a piece of material born under an alien sun, moving through our neighborhood for perhaps the first and only time. And that raises a new question. If there is no threat, why are spacecraft around Mars turning their instruments toward it so urgently? From the surface of Mars, 3I/ATLAS will hardly look like more than a faint speck. In fact, to some of the cameras orbiting the planet, it won't even fill a single pixel. That might sound disappointing, almost like a wasted chance, but this is exactly why scientists are paying close attention. It forces them to rely on spectroscopy, the method of breaking down the light reflected or emitted by the comet's gases. What looks tiny to the eye can still expose an entire chemical fingerprint, and that's where the real discovery lies. Orbiters around Mars are central to this effort. The Mars Reconnaissance Orbiter, though mainly designed to map the planet's surface, can reorient its instruments toward the comet. Alongside it, ESA's Mars Express and the ExoMars Trace Gas Orbiter are being prepared for targeted observations. Both missions carry cameras like the high-resolution stereo camera on Mars Express and the Cassis system on TGO. And while these cameras may only capture a pinpoint of brightness, the real power comes from their spectrometers. Instruments such as Omega and SpyCam on Mars Express and Nomad on TGO can split the light into detailed spectra. Through these readings, scientists can identify trace molecules like water vapor, carbon monoxide, and even organics that might boil off the comet's surface as it warms near the Sun. Ultraviolet spectrometers expand the coverage. NASA's MAVEN spacecraft has an imaging ultraviolet spectrograph that has already demonstrated success when it watched Comet Siding Spring sweep past Mars in 2014. This time, MAVEN will again be directed toward an interstellar object, with the Emirates Mars mission's ultraviolet spectrometer providing additional data from a different orbit. These complementary views are important because different wavelengths of light reveal different gases. Ultraviolet light, for instance, is especially good at highlighting hydrogen and oxygen released as water molecules break apart. Even rovers on the ground might play a role. Curiosity and Perseverance could point their sky-facing cameras up during the darkness of Martian night. While they won't get detailed structures like a glowing tail, they could measure brightness changes over time. Those measurements can be used to estimate how much dust and gas is being released, offering clues about the activity level of the nucleus. For day-to-day monitoring, these surface-based perspectives are unique because they complement the high-altitude data from orbiters. It's important to remember that none of these teams are chasing pretty pictures. The goal isn't to capture a blazing comet streaking across the Martian horizon. Instead, every instrument is tuned to uncover chemistry. What hidden ices are trapped inside, what gases burst free as it heats up, and whether the material resembles comets formed in our own solar system. That chemistry has been sealed since the comet's origin around another star, making it a pristine archive of alien formation conditions. If all goes well, these observations could tell us what kind of volatile cocktail 3I/A-TLAS is carrying with it across the galaxy. And Mars won't be the only vantage point. Other spacecraft across the solar system are also turning toward this fleeting visitor. If this comet isn't colliding with Mars, why are scientists treating it like treasure from another world? The reason is simple. 3I/A-TLAS is not bound to our Sun at all. It came flying in from the direction of Sagittarius, and it's already on its way back out. Its hyperbolic escape path proves that it formed around some other star system, and has spent billions of years drifting through interstellar space before crossing ours. Each time one of these objects appears, researchers know they may never get another chance to study material preserved since the earliest days of a completely different solar neighborhood. And yet the comet still holds mysteries close. Astronomers are not even sure of its size. Models suggest the nucleus could be only a few hundred meters across, or larger than 5 kilometers. That uncertainty shows why every new data point is valuable. The Hubble Space Telescope has already made a difference here. In July 2025, it captured an image of what looked like a teardrop-shaped envelope of dust flowing away from the core. Tracking that plume allowed scientists to refine their size estimates and to see how the nucleus behaves when heated by the Sun. It is activity like this that makes it possible to improve predictions and models. Why care so much about a patch of dust and ice? Because comets like this are untouched time capsules. Normal comets formed around our Sun, but interstellar comets carry chemistry from stars that may have formed long before ours did. In fact, some researchers note that 3I/A-TLAS might even come from the Milky Way's thick disk, a region that formed nearly 10 billion years ago during the galaxy's busiest era of star birth. Studying it is like opening a bottle sealed before Earth even existed. That is why every possible telescope and spacecraft is being recruited to watch it. The clock, though, is ticking. The observation window is short because the comet will vanish into the glare of the Sun after September 2025. Only when it swings far enough away in December will it appear again, meaning the months in between are crucial. To make the most of this limited time, missions across the solar system are coordinating. Parker Solar Probe and Solar Orbiter can catch it closer to the Sun. JUICE and Europa Clipper in the outer solar system might contribute distant checks. Mars orbiters and Earth-based telescopes are lining up coverage too, placing 3I/ATLAS under one of the widest observing campaigns ever assembled for a single comet. The real danger here isn't a comet striking Mars, it's the fear of destruction overwhelming the chance for discovery. 3I/ATLAS is only the third confirmed interstellar object we've ever seen. Each one opens a rare window onto material formed under another star and preserved for billions of years. Instead of a threat, think of it as an alien messenger. It carries frozen chemistry from the Milky Way's most active period of starbirth, evidence no spacecraft could ever bring back. And it makes you wonder, how many other hidden travelers are already passing through, unnoticed above our skies?